Hello, this is Mr. Bissonette with another episode of Math in the Classroom. Today we're going to use laws of exponents to simplify expressions. So we got our learning target up there. I can use laws of exponents to simplify expressions. I'm not going to go over all of them today. We're just going to go over a couple of them that we're working with as a class right now and then go from there. So first thing I like to do with students is to build up the concept of what's happening with the exponents. The way that we do that is something like this. 2 to the third power, what does that mean? 2 times 2 times 2. And then what does that equal? 2 times 2 is 4, times 2 is 8. Next, we'd have 2 squared. What does that mean? 2 times 2. And what does that equal? 4. Continue the pattern. 2 to the first power is going to equal 2. And this is going to equal 2. And then I have the students notice, what are we doing to get from 8 to 4 to 2? And a lot of times they pick up that we're just dividing by 2 each time, which is exactly right. So we know what the next answer is going to be. If we divide by 2, 2 divided by 2 is going to be 1. And if we follow the pattern, notice that we would have 2 to the 0th power. This is one of those ones that the students struggle to get. The way that I show this one is it's going to look like this. 2 to the first over 2 to the first. Again, if you subtract exponents, you get 1 minus 1 to get 0. That's kind of a shortcut, but to kind of see what's happening, we'll start off there. Now, continue this. If we divide by 2 again, 1 divided by 2, we could leave that as a fraction, 1/2. And notice that's where we get our negative exponent. So this is going to be 3, 2, 1, 0, negative 1. And we're going to see this 2 to the first power. And then if we continue 2 to the minus 2, we develop this saying, cross the line, change the sign. So once we cross, you might be asking what line? If we made this into a fraction, once we cross that fraction line, we then would change the sign of the exponent. And we can go either direction. If we're going above or below, cross the line, change the sign. If we want to change it from positive to negative, negative to positive, it works. What does that mean? 1 over 2 times 2, which equals 1/4, where if we continued that pattern, dividing by 2 each time, we would get there. So that kind of shows students what happens when we have any number to the 0th power. It's going to be 1. And what happens when we have negative exponents. I love starting out there, building that concept. All right, if you need to pause the video, write that down. To follow along, feel free. Once we have that, then I like to break it apart and look at this part of it. If we had something like x to the 5th over x squared, again, I start off with students asking them, what does that mean? And I get them to write it out as x times x times x times x times x. A little tedious, but I think it's really good to build that concept before we start taking the shortcuts. X squared, what does that mean? X times x. Now, again, I go with my students, what's 4 divided by 4? 1. What's 3 divided by 3? 1. What's negative 2 divided by negative 2? It's 1. What's x divided by x? And hopefully they all shout out 1. Correct. So we have 1, we have 1. 1 times 1 is 1, and we would get x to the 3rd power. Then, I don't normally kind of ask them to figure it out, but I start waiting for students to kind of realize, oh, we're just subtracting those exponents, 5 minus that 2 to get to the x to the 3rd. Once a student has noticed that or showed their classmates that shortcut, then I start talking about this. So if we go with order of operations, we start off with adding, subtracting. What's next greater? Multiplying, dividing. Next greater, we do something like squaring and square rooting. This could be x to the 3rd if it's to the third, then it'd be the third root. And then the next higher order, if we did something like 10 to the x, then we'd have log x, where that variable is now up into the exponent. And when we're working with these, whatever we are doing, so notice here we are dividing. What is one order less than dividing? Subtracting, and that's what we're going to do with the exponents. So since we're dividing here, we do one less, so we would go into subtracting 5 minus 2. And notice we have more x's on top, so our answer is going to be on top. I like showing students this because it kind of prepares them a little bit for calculus when they start differentiating, how we go down 1 degree each time we differentiate. Also, you know, it kind of is a great way for them to kind of associate the opposite functions of. So what's the opposite function of adding, subtracting, and seeing how those relate and correlate. So there's that. Once we have that, then we start hopping into some problems and working on simplifying our expressions. Now, I have expressions underlined over here. It's great to define our terms. What does that mean? Essentially, if we have equations, equations have equal signs. Expressions have no equal sign. So notice as I was going from one step to the next step to the next step, I'm not writing equals each time. They are equivalent, but they don't have that equal sign, so that's why we're calling them expressions instead of something else. So let's say we have something like 18 over x to the minus 4th y to the 5th over 24 x to the 6th, and we're going to go y squared. All right, first thing I'm going to do here is I'm going to take a look at this, and I'm going to simplify this just like the fraction that it is. What goes into both 18 and 24? 6. So I'm going to essentially divide by 6. Again, it's another creative form of 1. So we would get 18 divided by 6, which is going to be 3, and 24 divided by 6, which is going to be 4. All right, now notice I have a negative exponent right here. Again, this is the cross the line to change the sign. So here we would have x to the 6th times x to the 4th. Here we are dividing. What's 1 degree lower than dividing? Subtracting. So we're going to subtract them, 5 minus 2 to get our 3. And we have more up top, so our answer is going to be up top, y to the 3rd power. Now, using that same logic, here we're multiplying x to the 6th times x to the 4th. 1 degree lower is going to be adding. So we would add them together to get our final solution as 3y to the 3rd over 4x to the 10th. And this would be the simplified. And again, those expressions, we're not putting that equal sign in between. We're just simplifying step by step. It doesn't necessarily equal anything, but we're using our laws of exponents to simplify. So again, that's Mr. Bissonette. Thank you for watching. And that's kind of what we're working on in class right now as far as simplifying those expressions using laws of exponents. Thank you.